Hi. Alright, I got stuff to do. We got plenty of things to do. But my place is kind of dirty. And I don't really have a lot of space to set up everything for today. So we're gonna do a little bit of. Okay, let's do this. Yeah, very cool. I'm gonna do cleaning. We're gonna do cleaning time. I want to find a better way to get a timer widget and set that up. I'm gonna add a text box. Let's see. What the heck? Someone's talking to me. Oh. Right, I ordered food. Text. Need to add a news. Add a This is fine. Study time. Then it's cleaning time. There we go. Sick. Alright. I'm gonna find a hair tie, and then we're gonna do like 20 minutes of cleaning starting now. There we go. Might help audio a little better. Okay, ready to go. I can live around. I can live around garden really easily. That's a problem. Especially if but like it doesn't mean it doesn't affect. That part means it doesn't affect. Yeah, cleaning. Oh no! Oh no! Build. Away, kitty. Alright, it's over. Save the day. Pretty much haven't been eating a lot of it. So it's just taking. Keep cleaning. You're doing great. Getting a burrito soon. Ooh, this does open. The bottom part didn't open. I guess I have a bottom part. Oh no! Our table! It's broken! Cat's been knocking over stuff in the corner. So a lot of it's just on the floor. That's another thing. Start keeping your place messy. Pets have worse things to mess with. Fuck that. See it, it'll make you want to eat it. I'm growing an avocado. I'll let people know how it goes. Right now, I have the seed, and I peeled it, and I took the paper towel, and I wrapped that in. Well, I put water in it, and I wrapped that water, and I wrapped the wet towel. So okay. How much time do we have left? Good news. Okay, thank God that wasn't. We got 10 minutes. And running out of into the door. Oh, I'm getting a phone call. Timer's done. So, wow, that's weird. nap. Alright, there. Goals for the day are pretty simple. Study for the test on Monday. My goal is to, at the minimum, do 2 hours of study. Shouldn't be terrible. We're gonna be doing. I do practice questions. I'm gonna run through exam, like the Unit 1 review exam, and see if it things me. I guess I'll do the Unit 2 one. One will be a little more comprehensive. Yeah, like it should just keep my score and just say that I passed. Study material, I think. I hope so, anyway. It's burrito time. Welcome to Burrito Town. Okay. The agenda for the day. What's today? It's been a few days. January. Calls for today. Hours of math, and it's like 2-hour minimum. That's pretty much like what I want to focus on tonight. I don't really have anything else. We can, at the very end, we'll throw in a map. The map time. I like this. Should be chips. Alright, got chips. Man, we already did 20 minutes of cleaning, so that's awesome. I'm gonna try and organize my scratch paper a little better into more comprehensive notes. Maybe not. Like, I wanna at least be able to, like, draw a circle and be like, this is this. So I'm not gonna be able to, like, bring in any of my notes. I actually kind of need to go find a calculator. I don't have a calculator. I don't have my food. Here you go, kitties. And then, like, I took all these notes on in my thing. I might spend some time compiling a little bit. I just jotted down a lot of stuff. Okay, we'll just start from the very beginning. We'll do this all 1.5 speed. We'll start mowing this timer down. Minutes. Let's go. Okay.
Recognize and identify number systems. The first set of numbers we consider is the set n of natural numbers, also called counting numbers. If we extend the set of natural numbers by including 0 as an element, we have the set W of whole number. To extend the set of whole numbers, we include the opposite of all the natural numbers. The opposite of a natural number is a negative number and is written with a negative sign in front of it. To combine the set of negative numbers with the set of whole numbers, we have the set Z of integers. Rational numbers are numbers that can be written as a fraction, a quotient, or a ratio of integers, excluding the possibility of a zero denominator. All integers are rational numbers because we may write them with a denominator of 1. All terminating decimals are rational numbers. All repeating decimals are rational numbers. Irrational numbers are a number which is not a quotient of two integers. Some examples are the square root of 2, the cube root of 5, or the number that is represented by the Greek letter pi. The set of real numbers is the union of rational numbers and irrational numbers. Identify prime and composite numbers. Any natural number greater than 1 whose factors are 1 in itself is a prime number. 2, 3, 5, 7, 11, 13 are examples of prime numbers. Any other natural number greater than 1 is a composite number. 4, 6, 8, 9, 12 are examples of composite numbers.
This is the overview for finding the greatest common divisor. We're told here that the greatest common divisor of two integers, a and b, is the largest integer that divides them both evenly. Meaning, what's the largest number that'll go into both our a and our b? So let's choose two numbers, let's say 48 and 36. Well, in finding the greatest common divisor, we start out by finding the prime factorization of both of our two integers. If you've never seen prime factorization performed before, I'll go ahead and show you over here on the right the way of doing it. We'll start out with 48. Now let's just find a prime number that'll divide into 48, like 2. And 2 times 24 gives us 48. So now that 2 is a prime number, we leave it alone, but 24 is not a prime number yet. So let's break 24 into 2 times 12. Once again, our 2 is a prime number, so we leave it alone, but 12 can be broken down into 2 times 6. Once again, 2 is a prime number, but 6 can be broken down into 2 times 3. So now we're left with all prime numbers of 2, 2, 2, 2, and 3. Meaning, we could rewrite 48 as 2 times 2 times 2 times 2 times 3. Or, another way of writing that is 2 to the 4th times 3. The prime factorization of 36 is 2 times 2 times 3 times 3, which you can obtain by doing a prime factorization tree. Or this is the equivalent of 2 squared times 3 squared. So now, to find the greatest common divisor, we want to go through and find like prime numbers. So starting with 48, we have a 2, and we also have a 2 in the 36. Again, we have a 2 in the 48, and a 2 in the 36. Now, if we look at the next 2 in the 48, there's no more remaining 2's in the 36, so we do not use any more 2's. But we also notice that 36 has a 3, and 48 has a 3. 36 has another 3, but 48 does not have another 3. So our end result here for the greatest common divisor is 2 times 2 times 3, which is equal to 12. Now if you prefer dealing with powers, we notice that we could also rewrite 48 as 2 to the 4th times 3, and 36 is 2 squared times 3 squared. Well, the highest degree that they both have in common would be a 2 squared, and the highest degree that they both have in common for the 3 is just a 3 to the 1 power. So we could also write out 2 squared times 3, which again is 12. So quick review again of what 12 means. 12 is the largest number that will divide evenly into both 48 and 36. 48 divided by 12 is 4, and 48 divided by 36 divided by 12 is 3. Is 3.
In order to add or subtract fractions, it is imperative to have a least common denominator. To find the least common denominator, find the least common multiple of the denominators. What is the least common denominator of 1/12 and 1/8? We want to find out what the prime factorization of 12 is. 12 is equal to 2 to the second power times 3. 8 is equal to 2 to the third power. The least common multiple is a product consisting of each different denominator factor using the largest exponent that occurs for each factor. So each different denominator factor is 2 and 3. The largest exponent that appears for the 2 is 2 to the third power, and the largest exponent is just 3 to the first. So the least common multiple is 2 to the third power times 3, which is 24. To order rational numbers, rewrite each fraction with common denominators in order according to the numerators. List the following numbers in order from smallest to largest. 2 1/4, 13 6, 1, 52 20ths. The least common denominator is 60. 2 1/4 is equal to 9/4. To get the denominator of 60, we want to multiply the 4 by 15. To maintain the equality of the fraction, we need to multiply the numerator by 15 as well. 135 60ths. 13 6 times 10 tenths is equal to 130 60ths. 1 times 60 60ths is equal to 60 60ths. 52 20ths times 3/3 is equal to 156 60ths. Now we want to order from smallest to largest according to the numerators. The smallest numerator is 60. The next smallest numerator, 130. The third smallest, 135. And the largest numerator is 156. In order from smallest to largest is the number 1, 13 6, 2 1/4, 52 20ths.
Understanding positive and negative number operations, the overview. So let's start out by saying, let A be some positive number, which we'll just define that right now as 5. Let B equal some positive number, which we'll call 8. Let C be a negative number, which we'll call -2. And let D be some negative number, which we'll call -6. So one of the first examples you might encounter will be 2 We'll just write out positive numbers. So with addition, if we take A plus B, you see that we get 13, which is equal to a positive number. If we take A times B, we get 40,
This one's bad.
which is also a positive number. Next, we may have
Even at 1.5, it sounds slow as fuck.
negative numbers. So when we add two negative numbers, like C plus D, we get negative 8, which is a negative number. When we take C times D, we get positive 12, a positive number. Now let's see what happens when we have one positive and one negative number. Well, it actually depends on which number has a higher absolute value. So scenario 1 we'll call the absolute value of the positive number greater than the absolute value of our negative number. So let's see, the absolute value of A would be 5, and the absolute value of C would be 2, and 5 is greater than 2, so here we'll try A and C. So when we do A plus C, we get 3, which is a positive number.
Yay.
If we take A times C, we get negative 10, a negative number. And lastly, let's choose the absolute value of our positive number to be less than the absolute value of our negative number. So let's see, the absolute value of A is 5, and the absolute value of D is 6. So in this case, the absolute value of our negative number would be larger, which is what we want. So we'll use A and D for these examples. A plus D is equal to, let's see, 5 plus negative 6 gives us a negative 1, which is a negative number. A times D, so 5 times negative 6, we get negative 30, which is also a negative number. So in review, if both numbers are positive, or both numbers are negative, when they're multiplied, you will get a positive number. When both numbers are positive,
We know this.
Making conversions between units and measures is very important in real-world applications, and especially in scientific fields.
I fucking hate
Convert
this.
60 miles per hour to feet per second. We want to use equivalencies to find conversion rates to change one unit of measurement to another. We want to convert miles to feet, and we're given information that 5,280 feet is equal to 1 mile. We need to convert hours to seconds. To do that, we want to use the equivalencies. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds.
So I guess what you can't,
The
what you
equality
gotta
equivalence of
do
60 miles
this is make sure that you convert
divided by
it.
1 hour is maintained when we multiply by 1.
Remember, you're converting first
So we want to use the
miles
equivalencies
per
to find
hour.
conversion rates.
to feet per hour,
Let's look
then
at the
from
unit
miles,
hour.
or
It's in
then
the
from,
denominator.
oh wait, no, first
So
we're
the
gonna do miles
ratio
per
of
hour
those
to miles
hours in the
per
numerator.
second.
So the unit hours will be canceled out. So we know 1 hour is equal to 60 minutes.
And then we're gonna convert miles per
Now we need
second
to get
to
60 minutes in the
feet per
minute
second.
units in the denominator. So we put a minute
Stupid.
in the numerator. 1 minute is equal to 60 seconds. Looking at miles in the numerator, we want a mile in the denominator. So 5,280 feet divided by 1 mile. Each of these ratios is equal to 1, so we are maintaining the equality of our original ratio. If we multiply through, we can cancel units. We have an hour in the
Yeah,
denominator.
so you're
an hour in the
changing
numerator,
miles per hour to miles per
a
second,
minute
and then you
unit in the
change
denominator and a minute unit in the numerator. A mile unit in the numerator,
Miles
a
to
mile unit in
feet.
the denominator. So we're left with the units feet in the numerator and seconds in the denominator. 60 and 60,
She does a really bad job at
cancel out.
explaining this, though.
5,280 feet
I,
divided by 60 seconds. That can reduce down to 88 feet.
math people know how it works in their brain, but it's
So
a
60
fucking whole other science to communicate
per
how
hour.
it should work in your brain.
Is equivalent to 88 feet per second.
solving percentage increase and decrease problems. In solving these problems, there will be some original value, which we'll call x, will have a percentage increase or decrease, which
I
will be our
love
rate
doing
of
this
change,
shit.
which we'll denote as R.
It is great.
And after our original value
It's
has
so
been changed by some
effective.
rate, we'll have our new or present value. In a percentage increase problem, we use the formula x times the quantity 1 plus r equal to y. And in a percentage decrease problem, we use the formula x times 1 minus r equal to y. So let's try an example here. Martin's home was recently appraised at $96,000. He figured that it was a 60% increase
Whatever.
from the price he paid for the house in 1975. How much did Martin pay for his home in 1975? So here, x, our original value, will be the amount that Martin paid for his home back in 1975. We'll go ahead and multiply that by 1, and since it's a percentage increase, we'll have our plus 0.6 equal to, and our y, which is the new or present value, is 96,000. So let's perform the addition inside of the parentheses, and we'll get 1.6 x equal to 96,000. Now we divide both sides by 1.6 in order to solve for x, and we get that x is equal to $60,000. So the amount he paid in 1975 was $60,000. So now moving on to another example. So this example says, a used car's current value is $1,400, which was a decrease in value by 30% since the purchase. What was the original cost of the car? So again, the original value, x, is our unknown, times 1, and since we have a percentage decrease problem, we'll have minus our rate, which is 0.3, equal to, and y, which is the new or present value, is $1,400. So let's compute the subtraction inside of the parentheses. So here, 1 minus 0.3 is 0.7 times x equal to 1,400. If we divide both sides by 0.7, we get that
Motherfucker's
x
still
is equal
going.
to $2,000. Overview for using exponential rules to evaluate expressions. The exponential rules are, for a zero exponent, if a is any non-zero real number, then a to the 0 power is equal to 1. What this means is that any number raised to the 0 power is just equal to 1. You can test this out on a calculator if you'd like. The negative exponent rule says, for any natural number n and any non-zero real number a, then a raised to the negative n is equal to 1 over a raised to the positive n. So whenever you have a negative exponent, it means basically if it's on top, you throw it to the bottom, and if it's on bottom, you throw it to the top, which will make the exponent become positive. So another example would be 1 over a to the negative n. Well, that would be equal to a to the positive n over 1. The product rule states, if m and n are natural numbers, and a is any real number, then if we have m, or rather a, raised to the m power times a raised to the n power, then it's just equal to a raised to the m plus n power. So when you're multiplying two like terms, you add the exponents. The quotient rule follows the product rule closely, except for the fact that you use subtraction instead of addition. So if we have a to the m divided by a to the n, this is equal to a to the power of m minus n. And lastly, we have the powers rule. If a and b are real numbers and m and n are integers, then if we have a raised to the m power, all that raised to the n power, that is equal to a raised to the m times n power. So a power to a power, you multiply the powers. Now if we have two terms, let's say a times b, both being raised to the m power, that's the same thing as saying a raised to the m power times b raised to the m power. So whenever you have a product going on with two different variables raised to the same power, it's the same thing as the first number raised to that power times the second number raised to that power. And the same thing holds true for a division. If we have a divided by b to the m power, that's the same thing as a to the m divided by b to the m. So let's use this information to run through a quick example. So let's say we have 5x to the 4th y squared over x squared y cubed plus x squared times, or x to the 4th times x squared, all that times y to the 0. So working with the first term, we'll have a 5, and since we have an x to the 4th divided by x squared, we'll use the quotient rule and subtract the powers. Then we'll be left with an x squared. Next we have a y squared divided by y cubed. Again, we'll use the quotient rule and subtract. 2 minus 3 is a negative 1. Well, y to the negative 1 is the same thing as 1 over y. So we'll put a y in the denominator. Next, we have x to the 4th times x squared in parentheses. And we'll use our product rule by adding those exponents to give simplifying radical expressions. In general, we say that a radicand of the form nth root of a is simplified when the radicand a
I'm really
contains
bad
no
at
factors
this.
that are of perfect nth power, contains no fractions, and is not in the denominator of a fraction. So let's run through an example here. We have 4 times the cube root of 16 plus the square root of 32. The way we go about solving these is we want to see are there any perfect cubes that'll divide evenly into 16? Well, let's go through the perfect cubes that we know. Let's start out with 2 times 2 times 2, which is 8. Does 8 divide evenly into 16? Well, yes, it does. So we'll have 4 times the cube root of 8 times 2. Now looking at the 32, we're dealing with square roots, so let's go through the perfect squares that we know. Well, 2 times 2 is 4, and 4 goes into 32. So we could rewrite this as plus the square root of 8 times 4. Well, if we look at 8, we could actually break 8 down into 4 times 2. So on the next line, we'll write 4 cube root of 8 times 2 plus the square root of 4 times 4 times 2. So now looking back at the first term, we can pull that 8 out of the cube root function, and we can pull it out as a 2, since the cube root of 8 is equal to 2. So we'll have 4 times 2, since we just pulled that out, times the cube root of 2, which is still left inside of there, plus, well, that 4 we can pull out of the square root by
It's
taking
like, why
the
are
square
you
root of
able
4,
to
we
do
get
that,
2.
you know?
If we
Like,
pull the second 4 out,
I hate
we take the
math
square root of
because
it
it's
when we pull it
like
out.
you just
So
learn
times
rules and
2.
you don't really know why you can do the
And
rules.
lastly,
You just know
we'll be
you
left with
can
still
or
a
you
square root
can't.
of 2 on the inside. Now we just multiply our outside term. So 4 times 2 is 8 cube roots of 2 plus 4 square roots of 2. So again, what we did with the first term, since it's being cube rooted, we wanted to know, are there any perfect cubes that are inside, or that divide into 16? And with the square root function, we wanted to know, are there any perfect squares that'll divide into 32? And after we found those numbers, we just performed the cube root and the square root onto those numbers and pulled them out as whole numbers.
Please say that again.
Square roots of 2. So again, what we did with the first term, since it's being cube rooted, we wanted to know, are there any perfect cubes that are inside, or that divide into 16? And with the square root function, we wanted to know, are there any perfect squares that'll divide into 32? And after we found those numbers, we just performed the cube root and the square root onto those numbers and pulled them out as whole numbers.
What if you don't know how to square root? Alright, let's try this. Which contains only whole numbers. You can choose more than one, right? No, you can only choose one. I don't think 0 is a whole number though, is it? Oh man, why did I forget this? Is 0 a whole? I'm gonna cheat. 0 is a whole number, but not a natural number. Okay, that's good to know. So this is correct. Not prime numbers? Well, that goes this one probably. These all seem prime. It's the greatest common divisor. 525. Do. So, like, if I'm correct, we need to factor out both of these. I need to get, like, a software where I can draw on here. That way people can see my scrap work. I need also a fucking... Oh, our time is up. Oh well, we're gonna get through this test and then we can take a break. Need to get that better calculator tomorrow. 252 times 2. And then it's 126 times 2. 63 times 2. You can't divide that by 2, but you can divide it by 3. See, this is what I'm saying when, like, that lady was, like, explaining how to, like, do whatever with, or how to order the rational numbers. It's like, well, you already knew the least common divisor, so it's like, you already know how to, you can just plug this in. Like, you're not even doing the dirty work. Alright, 21 is divisible by 3. That's 3 and 7. And you can't get any better than that. Can't divide 525 by 2. I'm guessing you can't divide it by 4 either. Oh, but you can divide it by 3.
Roger, 0J, and I feel fine. Discovery Houston, press to ATO.
And then 175, 35 times. Wait, and then 35 is 5 and 7. Okay,
3, 2, 1, 0, 0. Discovery, go and throttle up.
I'm not really like, gosh. Yeah, we're gonna look up. Here. What do you mean this site can't be reached? There we go. I was like, I pay good money for this site. Because this site teaches you shit. I don't think I'm doing this right. This is a shot and then oh, greatest. Okay. That does work. Wait. Okay. It's 21. Okay, so the greatest common divisor, GCD of A and B, is the largest positive number that divides both A and D, B without a remainder. I need to see steps here. It's true. We got down to this part, alright. Oh, and then you find what's in common between those two, which is a 3 and a 7. 3 times 7 is 21. So this answer is 21. What's the least common denominator? Okay. This is mainly to check the answer. Okay, so I think to find the least common denominator, don't you just factor 8 and 15? So factoring 8 out. You just get lots of 2s. And then 15 is 3 and 5. Okay, let's see. Okay, you're an asshole. There we go. It's 120. Explain. So you factor those out, which is what I did. Then you alright, to find the multiply each factor greatest number of times it occurs. Oh, so we have to squeeze all of these together to find the least common denominator. So to find the greatest common denominator, you find the numbers that the numbers that both numbers have in common. But if you find the least common denominator, you're taking all the prime factors, multiplying them together. Good to know.
Every core computers now have primary control of critical vehicle functions.
I should, let's see. Common. Okay. So we're gonna have to order all of these from smallest to largest. And in order to do that, we're gonna have to find the least common denominator of quite a few of these numbers. Let's see. Order rational numbers. I feel like super duper check. Yeah. Gotta find the least common denominator. Okay, that's easier to do, arguably, with all these numbers because you just combine all the terms at the end. Okay, so we got a 1, a 6, a 15, an 18, and a 21. Wow, we really lucked out with this 1 here. It's just 1. 6, 2, and 3. 15, 3 and 5. 18. 2, 6. Sorry, that's 2 and 9. And that's 3 and 3. 2, 3. So we're taking 1 times 2 times 3 times 3 times 3 times 3 times. Okay, all of these down here. We got 1 1, we got 2 2s, we got 3 3s, we got 4 3s actually. Got 1 5, got 1 7. All right. Oh, but the terms cancel each other out, don't they? So we're not combining all this junk together quite as much as I thought. you go, kitty. Can't hang out right now. Okay, 6, 15, 21. So. Got all those. That's all correct. Compute a number comprised of factors that appear in at least one of the following. Oh, so you have to do at least one number comprised. Well, then why are there two? Oh, at least. Oh, so you have to pick one. Is that what it's saying? I'm not really sure. So we're taking 1 times 2 times 3 times 3. Oh, so if you have 2 2s, you just put 1 2. If you have 4 3s, you're gonna put 2 3s. Wait, there's 5 3s here. Son of a bitch. I don't know how this works at all. This is really dumb. Okay, and then that equals 630. So we go back here, we plug in, we got 630 that all these numbers go into. Wait, no, I got 20. Let's see, 630 divided by 6 was 105. 105 times 5 is 525. You can kind of almost figure out kind of where everything is supposed to be anyway. But it's okay. 42. Let's see. 630 divided by 21. 30. Okay. The answer is 3, 13 over 21. Then the answer is 26 over 15. Then the answer is 1. Then the answer is 16 over 18. Then the answer is 5 over 6. Suppose A and B are real numbers. Okay, I'm pretending they are real numbers. B is less than A. A is less than 0. And B minus A is. Okay, if B is less than A is negative because it's less than 0. Then, so that means that B is negative, and B minus a negative. Well, okay. So let's try, -1. Wait, B is less than, so, okay. I mean, A is -1. I don't think there's enough info to tell. No, that can, well, yeah, it's negative. Convert the 137 yards per minute into feet per hour. Gosh. It's 3 feet in 1 yard. Okay. 137 yard per minute into feet per hour. So first thing we'll want to do is change the yards per minute into yards per hour. So 137 over 1. So that would be like 137 over 1 times 60 over 1? Question mark? How do you divide that? Alright. Per yard per min to yard per hour. So we're dividing these two. So am I essentially just dividing 137 from 60? Here, let's try 1 divided by 60. That gets 1.66667. Yeah, so we're basically just dividing 137 by 60. You know what? It probably will be easier if we convert yards per minute to feet per minute. Because there's 3 feet in 1 yard. So first we have to multiply these two. Times, so 137 times 3. Equals 411 feet per second. Wait, per minute. And I think you just divide that by 60. So 6.85 feet per hour. Okay, after you graduate, you get a job with the permutation group, earning $12.10 a week. 2 weeks later, your pay is cut 17%. What percent cost of living raise would you need to get back to making $12.10 a week? Alright, so we need to do... So first we need to find what amount we got after our pay gets cut in order to find what we would need to get back. So we're looking at $1,210 times 1 minus 0.17. I think that's how you do that. Just double check here. Dang, this isn't the way that I'm being taught to do it. Here, I guess I'll just do this and hope that it comes with the same answers. Okay. So that was 1004.3. I think that's a reasonable number to get from that. Now, plug in a new one. Well, that's 1 plus r, but so we should take all right. This pay raise calculator. Pay before raise. Let's see how much I was making a week. Not the right number. Pay after it. What if we add a negative to this? Yeah, okay, so I got that one right. That's awesome. And then let's say I make 1004.3. And now I'm making that much. 20.48%. Which I got correct. On my calculator. I want to see the history. Show me the whole shebang. There we go. Okay. Simplify the following with no negative expressions. I like simplified problems because I can just go simple. So we got a parentheses, 2x to the 5th, y to the 2nd. Then there's parentheses for this weird thingy, the negative 2nd. Okay, So I think the first order of business is to free the parentheses. So you gotta do the... We're gonna get 2x to the 20th, y to the 8th, weird thingy imaginary number to the... Like that might be 8, but wouldn't that be positive? Because it might just be this one, guys. Ugh. Well, cube root of 32. Does this do simplest radical form? Well, it'll probably do simplify. -7 is the square root 12. And it's like the cube root of like 32. Shit is whack. Show me the Morty. 14. I'm just gonna... write this down here. Maybe I'll understand it. Oh yeah, it is. No, it doesn't even say it right now. Need black borders. Oh well. Man, I can't tell you how this works at all. Why are the steps locked? Show me these steps. I want all of them, bro. I want all the steps. Ugh. That was tough. Okay. I think the next time I'll be able to oh. It was 6. Alright. Messed up on number 2. Oh, I did greatest to least and they wanted least to great. Oh, come on. Oh, I know what I did. I divided by 60 instead of multiplied by 60, and that's what fucked me up. Good thing I already passed it. Okay, well, it's break time. There's big break time. Okay, 10 minutes. What did we learn? We learned read the questions carefully. That's what we learned. Good old 10-minute break. So yeah. That was something. Let's see. Let's go to the next one. Account. All right, so we can probably skip applying the counting principle. That's pretty easy. You just I will get my notes out. I don't remember if I have Obsidian on here or not. Thought I did. You check my phone to see if I already paid for this. Or have an account at least. I don't think I paid for it. Hey, there it is. Boom.
Understanding the terminology of algebra. First, a constant represents a quantity that does not change. It may be a numeral or a symbol whose value is taken to be a constant. Examples of this would be numbers like 4 or 3.8, or sometimes symbols such as pi, which is approximately 3.14, but it's something that never changes. There's also c, which is denoted as the speed of light, which is used in many calculations, but no matter what calculation you use it in, it'll always be the same numeric value. The next term we have is a variable. A variable is a symbol, usually a letter from the alphabet, used to represent a value from a particular set, usually the set of real numbers. An example of a variable, the most common example that we see, is x, where x is used to denote some real number. Next, we have the term coefficient, which is used to signify something that multiplies something else. Or more specifically, if we had 3x, the coefficient in this term would be the 3, because it's the number that is multiplying our variable. Variables and constants can be combined with the operations of arithmetic to produce algebraic expressions. So a simple example of this would be something like 3x plus 2. Or another example would be like 5x minus 8y over 12. Where each of these are just combinations of numbers, variables, everything. The whole 9 yards, as they call it.
I don't know.
Algebraic
what I'm
terms
doing
are
with
part
this.
of an algebraic sum.
Let's learn
Therefore,
it
terms
later.
in an algebraic expression are separated by addition or subtraction. And those terms are called algebraic terms. So let's look at our first algebraic expression, the 3x plus 2. The two algebraic terms in this expression are 3x and 2. Lastly, we have here two terms are like terms if all parts of both terms except the numerical coefficients are the same. An easy example of like terms are, let's say we have 2x plus 5x. Well, they both have the x in common. The only thing that differs on these two are the numeric values, the 2 and the 5. So here the like term is x. Sometimes you'll see something like 3 square roots of 2 minus 1, or let's call it 2 square roots of 2, where in this example, the square roots of 2 are the like terms, and then the 3 and the 2 on the outside are the numeric coefficients. So here the like terms would be the square root of 2's. And when you have like terms, it just means that you can combine them and simplify it into just one term. So like 2x plus 5x gives us 7x, and 3 square roots of 2 minus 2 square roots of 2 gives us simplifying algebraic expressions. The order of operations are as follows: parentheses, exponents, multiplication, division.
I know this.
Solving literal equations. It is useful in applications to be able to change the roles of the independent and dependent variables in equations. An example here: solve the following equation for x. We have 5 divided by x minus 2 equal to y. So we want to solve this equation for x. So the first step is we want to get the x term isolated. And we do this by adding 2 to both sides. So we get 5 over x equal to y plus 2. Next, since we have an x in the denominator, we need to get that out of the denominator, since that's what we're solving for. We do this by multiplying both sides by x. So on the left side, the x's cancel out, and we're left with 5 equal to y plus 2 times x. Now, since we have x times some quantity, we want to divide both sides by that quantity in order to solve for x. So we're going to divide both sides by y plus 2. And as an end result here, we get x equal to, because on the right-hand side here, the y plus 2's cancel out, and we'll have 5 over y plus 2. Multiplying binomial expressions. I'm going to go ahead and define a couple terms here first. A polynomial is an algebraic expression containing one or more terms, and those terms are usually variables raised to some degree. And a binomial is just a polynomial with 2 terms. Now before we start multiplying binomial expressions, let's start out with an easier example that's going to show us the distributive property and how to use it. So let's say we have a times the quantity b plus c. The distributive property tells us that we're going to take the a and multiply it through the parentheses. And by doing that, we'll multiply it by each term inside of the parentheses. So here, the first part, a times b, will give us ab plus a times c, which is ac. So now let's use the distributive property to multiply two binomial expressions. So here, the first term in the first set of parentheses, the a, is going to be multiplied by both terms in the second set of parentheses. So we'll have a times c, which will give us ac, and we'll also have a times d, which will give us a plus ad. Now, we'll take the second term in the first set of parentheses, factoring quadratic equations. Writing a polynomial as the product of two or more polynomials is called factoring the polynomial. Factoring the quadratic x squared plus bx plus c is done by first finding the pairs of numbers whose product is c. Then, with those sets that we just came up with, we need to find the one whose sum is b. So let's run through the example here of x squared minus x minus 6. So first, we're going to find the pairs of numbers whose product is c, which in this case is negative 6. So we're going to take negative 6 and find all the sets of two numbers that when multiplied will give us negative 6. So with negative 6, we have 1 times negative 6. We have negative 1 times positive 6. There's negative 2 times 3, and negative 3 times 2. And those are all the pairs of numbers that when multiplied will give us negative 6. So now, step 2 says, of those pairs that we found, we need to find the pair whose sum is b. Well, in this case, b is negative 1. So if we add the first two, 1 plus negative 6, we get negative 5. Negative 1 plus 6 is positive 5. Negative 2 plus 3 is 1. And negative 3 plus 2 is negative 1, which is what we want. So now with this information, we can go ahead and factor our polynomial. So I'll go ahead and set up two sets with parentheses. We'll put in an x in the first one and an x in the second one. And we'll throw in a negative 3 and a plus 2. So now let's check our answer real quick. If we take the first term in the first set times the first term in the second set, we'll get x squared. We'll take the first term and the second term there. We'll get a plus 2x. If we take the second term in the first set and the first term in the second set, we'll have minus 3x. And lastly, we'll have negative 3 times 2, which will give us a minus 6. So now we'll combine like terms, and we have an x squared minus x minus 6, which is what we started with.
Wow, super cool. So how am I going to remember this? Factor quadratic equations means that you have to find the pairs of numbers whose product is c, then of the pairs, find the pairs whose sum is b. Tomorrow I'm gonna write these down and like get better notes. But today we're just trying to get through some
Solving
practice
linear
problems.
word problems. Many real-world situations can be modeled with linear functions. It can be very tricky sometimes setting up a linear equation. So let's go ahead and run through this example. And hopefully I can help you recognize what we're looking for while setting up these equations. So our example here says, to earn money for a new car, Julie is making and selling bracelets. Her weekly costs for advertising and phone calls are $30, and each bracelet costs $1.50 to produce. If Julie sells the bracelets for $4 each, how many bracelets will she have to sell each week to break even? So let's call Julie's expenses E, and her revenue we will denote as R, and X can be the number of bracelets that are sold each week. So let's set up an equation for E, our expenses. Well, there are two types of expenses in this problem. There are weekly costs for advertising and phone calls, which are $30. Those are costs that are going to occur every single week. It doesn't matter if she sells one bracelet or 100 bracelets, she'll still only be charged $30 for her advertising and phone calls. This is sometimes referred to as a fixed cost. So here we'll have E equal to 30, and the other half of the expenses are the bracelets, which cost $1.50 each to produce. This is affected by whether she sells one bracelet or 100 bracelets. So here we'll have a plus 1.5x, where x is the number of bracelets sold, and so each time she sells one, her expenses go up $1.50. Now for our revenue, it says that Julie sells the bracelets for $4 each. So every time she sells a bracelet, she gets $4. So we denote this as 4x. Now we're looking for how many bracelets she will have to sell each week in order to break even, or in other words, to start earning a profit. So break even means that revenues are equal to expenses, or the money coming in is equal to the money we paid out. So here we'll plug in our two equations. For R we have 4x equal to, in our expenses equation, 30 plus 1.5x. Now we just need to solve this equation for x to find out the number of bracelets. So we'll subtract 1.5x from both sides, and we'll get 2.5x equal to 30. Now if we divide both sides by 2.5, we'll get x equal to 12. So this means that she must sell 12 bracelets per week in order to not be losing money. Using function notation. If an equation is a function, then the equation can be written in function notation, y equals f of x. The point x comma y can be written as x comma f of x. The two main types of problems you will see are when we are given what x is, or when we are given what f of x is equal to. So let's run through the example f of x equal to negative 5x plus 6. And next, the other set of information we're given is to find f of negative 3. So here, instead of it reading f of x, it says to find f of negative 3, meaning we replaced the x with a negative 3. So on the next line here, we'll write f of negative 3 equal to, well, since we plugged in a negative 3 for that x there, what do you think we're going to plug in for that x there? You guessed it, a negative 3. So we'll have negative 5, parentheses, and instead of x, we have a negative 3 plus 6. F of negative 3 equal to, if we multiply that out, we get.
This is pretty self-explanatory after they explain the function. Determining slope is y equals mx plus b,
Determining
right?
the slope of a line, the graphical approach. The slope of a line describes the direction and steepness of the line. The slope of a line is referred to as m. A line with a positive slope rises from left to right. A line with a negative slope descends from left to right. The following figure describes lines with various slopes. If we look at the blue line, with slope m equal to 1, we get this from the equation y equal to x. If you look at the bright green line, with slope m equal to negative 1, we get this from the equation y equals negative x. These two lines are helpful when approximating the slope of other lines. So now let's say we have a slope that's greater than 1, or m greater than 1. We have a line that is steeper than m equal to 1. If we have m between 0 and 1, then we have a line that is less steep than m equal to 1. So if we look at the red line, with slope m equal to 2, we know that 2 is greater than 1. And when comparing the red line to the blue line, we see that the red line is steeper than the blue line. And if we look at the darker green line, with slope m equal to 0.5, well, 0.5 is smaller than 1, and we see that the dark green line has a slope that is less steep than the blue line. And so now looking at our negative slopes, if m is less than negative 1, we have a line that is steeper than m equal to negative 1. And if m is between negative 1 and 0, we have a line that is less steep than m equal to negative 1. So if we look at the kind of aqua green colored line, which has slope of m equal to negative 2, we know that negative 2 is less than negative 1, and if we compare that line to our line of m equal to negative 1, we see that the negative 2 is a lot steeper than the line with slope negative 1. And looking at the olive colored line, with slope m equal to negative 0.5, we see that it is less steep than our original green line of m equal to negative 1. So looking at the example down here, we need to match the lines on the graph with their appropriate slope. If we look first at the blue line, line A, we see that it descends from left to right, meaning it has a negative slope. So we know it's either going to be number 2 or number 3. We also see that the blue line is fairly steep. So that means it's going to be number 2, which has a steeper slope than number 3. If we look at the red line, line B, we see that it has a positive slope since it rises from left to right. Well, the only option for a positive slope is number 1, which is a slope of 1/4. And lastly, the green line, line C, well, we see it descends from left to right, so it has a negative slope, and it's also a little bit less steep than line A, So it fits perfectly for our third slope. Graphing lines by graphing intercepts. Another method for graphing a line is to graph the x and y intercepts, which is where the line crosses the x and y axis. The following line has a y-intercept at 0, -6, and an x-intercept at 2, 0. Notice that the y-intercept occurs when x is equal to 0, and the x-intercept occurs when y is equal to 0. The x-intercept is also known as the horizontal intercept, and the y-intercept is also known as the vertical intercept. So down below in our example, we have matched the following equation to its graph. Y equals 1/3 x minus 1. Well, the minus 1 on the end tells us the y-intercept. Because to find the y-intercept, we plug in 0 for x. Since above it said notice that the y-intercept occurs when x equals 0. So let's write that out real quick. We have y equals 1/3, and we'll have 0 for x minus 1, and we get y equals -1. So we know we'll have the point 0, -1. Now, looking for the x-intercept, this occurs when y is equal to 0. So if we plug that into our equation, 0 equals 1/3 x minus 1. Now solve this equation for x. We add 1 to both sides. We get 1 equals 1/3 x. Multiply both sides by 3. And we get x equal to 3. So another point is going to be 3, 0. So which graph contains both of these points? Well, A is out of the question, because it has neither. B has the point 0, -1, but it also has -3, 0, which we don't want. And C has the point 0, -1 and the point 3, 0. So C is the graph that corresponds to our equation above.
Okay, so intercepts are when the lines hit 0, when the lines cross the x and y axis, which means that one of those are going to be 0. So to find the y-intercept, you got to make x 0. That makes sense. And then to make the x-intercept, you got to make y 0. That makes sense. Okay. Let's do this. Okay, greatest common divisor of 504 and 350. So if we remember from last time, greatest common divisor is when you take the common variables and multiply them together after you factor. Let's get the trusty phone calculator, which we'll have until we'll get our handy dandy calculator. Okay. Okay, so it's gonna be 2, 3, 5, 7. Wait, no, it's the stuff that they have in common, which is the 2 and the 7. Which is 14. Let's double check. Yes, I'm correct. It's 14. Okay. So we're doing in 1577 inches per second. Into meters per minute. There are 2.54 centimeters in 1 inch and 100 centimeters in 1 meter. So the first thing I should probably do is convert it into centimeters. – 4,005.58 centimeters per second. And now we need to convert this into meters per second. So 100 centimeters in a meter. So we're at 40.00 or 0588 meters per second. And then you just divide this by 60, don't you? Okay, we're gonna do inches per second. I never do these right. 2403.348. Okay, yeah, okay. Sweet. So I did it right. I just accidentally. There we go. I mean, I didn't do it right until I switched it, but Stacy's house recently appraised as 220K. She calculated that was a 19% increase from the price she'd paid. How much did Stacy pay for her house in 1995? Okay. So we're looking at X times 1 plus 0.19 equals 220. Okay, so X times 1.19. So we're gonna divide 220K from 1.9, or 1.19 from 220K. So she sold it for here, we'll do this. Oops, let's do minus 19. All right, that's correct. Simplify the following with no negative exponents. Okay. Okay. You take that y. Okay, first let's write this down. Simp. And then we got the negative 2, the negative 1, Well, if we take negative exponents and move them down and flip them to the other side, then they flip their negative. So, when we do that,
Discovery, go and throttle up.
Discovery's 4 computers now have primary control of critical vehicle functions.
if the first power times oh shit. Or the third power will bring everything to the top down. That gives x the 7th, y to the 9th. What's negative 4 to the third power? It's not. So we got negative 64. And then we're going to bring this negative 2 up by dividing. So I think it's this one. Can't confirm whether that's positive or negative, but oh, sitting here all day. Simplest radical form. Oh, it's the cube root of 32. Alright, so with the square root of 8, you can pull 2 out of it and get square root of 2. So, sim 5 square root of 8, then 6. So I used to use 3 letters followed by 3 digits on its automobile license plate. Use the counting principle to find the number of distance. Gosh. Okay. Is there 24 or is there 26 letters in the alphabet? I feel like we've been listening to the same fucking lo-fi shit. Alphabet. 26. Three letters followed by 3 digits. Now for digits, when you're doing digits on a license plate, 0 also counts. So you're going 1 through 9 plus 0, so that's 10. Okay, so this is pretty easy. 26 times 26 times 26 times 10 times 10 times 10. 17,500. Oh no, 17,576,000. Okay. Which of the followings are terms of the expression? What do they mean? Terms in math. Ow. Oh, okay. I know what we have to do. There we go. Simplify the expression. Okay, so I think what we should do is probably free up everything that's in these brackets. And the cool thing about that is we got this is 0, which makes this a 1. So all that's holding this back area back is this negative. So that whole bracket is just 3. We got 2 minus 1. Negative 2 minus 1. Which is just negative 3. Times negative 3. Which is 9. Oh. 2 times 2 is 4. 2 times 4 is this just 8 times 12? Yeah. This is 96. Solve for y. Can't remember what you're supposed to do. You want y to get out of the denominator, but I don't feel like you. Does that mean you multiply everything by y? Negative y? No. I need to plug this in. Hey, don't do that. Stop. Knock it off. Well, yeah, let's just do the easier thing. Subtract 8 from both sides. 2 for y equals x plus 1. And we do multiply everything by y. I was right. Okay, that's really good to know. So that means we got negative 2 xy plus y. And we're going to factor out the y. And we're going to divide both sides by x plus 1. Y equals 2 over x plus 1. Whoa. Distributive property, x squared plus 5x. Oh wait, okay. Factor the quadratic expression. Okay, so they're throwing me a curveball with this whole like it's 4x here. X squared plus 4x minus 32. Okay, so for ax squared plus bx plus c, find u and v such that u times v equals a, and u plus v equals b. U times v equals a, but a is 1. Okay, what? Yeah, a equals 1, b equals 4, c equals negative 32. We have to do it in a way that u times v is going to be equal to a times c. So something... Where do we plug u and v into? Oh, okay. Oh, so... u times v has to equal negative 32, and u plus v has to equal 4. I'm really bad at this one. I'm gonna Hail Mary this one. Cat, stop. Wait, so okay, so that's 5 parts. 92 divided by 5. It's 18.4. I'm very confused. Where they got the 23? Oh. -6 times -3. The positive 18 plus 3 is 21. Negative of -3 equals 21. -21 equals -6 x plus 3. Subtract 3 from both sides. 18 -6x. Divide both ends by that's 12. No, that's not true. Slope it. What? Okay, so it's positive. Okay, there's two possible right answers here. But then that is a negative. So we got the y-intercept of 0, -6. Now we're just gonna make y 0. Do I have to multiply both sides by 6 to get rid of this? Six over 5 is -1.2. Here we'll just do it this way. Y equals it's 5 and 6. I just need to figure out how. Oh, did they just multiply both sides by -6? Sometimes the answer's right in front of my face and I just like don't see it. Four is 11. I got 15 on this last time. Oh, really? Okay. 80. I fucked up somewhere, but can't tell you where. .3. Well then, the internet was wrong. Wait. Oh, so it's in a 6 cup. Oh. I gotta add them together next time. Oof. We'll watch the next 2 units, but I'm not doing another exam on these ones. These take a while. It's been already a few hours. But take a quick break. Okay. Do this. Squeeze this into my brain.
Solving direct and indirect variation problems. If two variables both increase proportionally, then their relationship has direct variation. If one variable increases while the other decreases, then the relationship has indirect variation. Direct and indirect variation relationships involve a variation constant, k. Direct variation is modeled by y equal to k times x. And indirect variation is modeled by y equal to k divided by x. When working with direct and indirect variation problems, the first step is to find the variation constant k. Then the problem can be completed. So let's run through this example here. The profit from selling shoes varies directly with the number of shoes sold. Jack's shoe shop sells 120 pairs of shoes for a profit of $1,920. How many pairs of shoes will he need to sell in order to make a profit of $4,000? So since we're dealing with direct variation, we'll use the equation y equal to k times x. And we'll use the information given in the problem in order to originally solve this for k. So here, we'll plug in for y, $1,920 equal to 120 for our x, so k times 120. Now solving this for k, we divide both sides by 120. And we get that k is equal to 16. So now we can rewrite our equation as y equal to 16x. Now the last sentence says how many pairs of shoes will he need to sell in order to make a profit of $4,000. So if we plug in 4,000 for x, or for y, equal to 16x, divide both sides by 16, we get x equal to 250. So the answer here is he needs to sell 250 pairs of shoes. Now let's run through an example for indirect variation. We have here the number of wing beats per second for any bird in flight varies indirectly with the length of its wing. A herring gull flaps its wings at a rate of 2.8 wing beats per second and has a wing length of 24.1 centimeters. Supposing that the variation constant remains the same, find the number of wing beats per second for a bird with a wing length of 15 centimeters. So let's set up our indirect variation model, y equal to k divided by x. So now let's use the information we're given in the problem. Let's plug in 2.8 for y equal to k divided by 24.1. Now to solve for k, we're going to multiply both sides by 24.1. And 2.8 times 24.1 is equal to 67.48, which is our k. Now we can reset up our equation of y equal to 67.48, which is our k, divided by x. Now we want to find the number of wing beats per second for a bird with a wing length of 15 centimeters. So we're going to plug in 15 for x. So here we'll have y equal to 67.48 divided by 15. And when we compute this, we get approximately 4.5 wing beats per second. Solving absolute value inequalities. The geometric definition of an absolute value is the distance from x to 0 on a number line. So here we have ourselves a number line. Now what this is saying is, let's say we have the number 5 out here. The distance from 0 to 5 is 5. If we were to count it out, we have 1, 2, 3, 4, 5 lengths outward. Now let's say we have negative 4. The distance from negative 4 to 0 is positive 4, because distances are always a positive value. So if we were to count out from 0, we would go 1, 2, 3, 4. So the absolute value of a number will always be positive because it represents the distance that number is from 0. So let's look at a couple examples like the ones you'll see in your problems. Let's say we have the absolute value of 3x minus 2 less than negative 4. Well, earlier I stated that when you take the absolute value of any number or polynomial, your end result will be positive.
Okay, this is hard for my brain to actually keep in the learning mode after this long of already doing that. So we might call it a night. We'll be back bright and early tomorrow. And this is going to be all we do all day. So, looking forward forward to a long one tomorrow. Well, stay strong, stay disciplined. Every little bit is a little bit of something that we wouldn't have done otherwise had we not committed to it. So, good job, everyone.